Have you ever wondered why energy never just disappears? Whether you're pedaling a bike, heating water, or turning on a light, the energy in the system doesn't vanish. This is thanks to the law of energy conservation. Welcome back to Science Bites. Today we're going to dive into one of the most fundamental principles in physics, the law of energy conservation. The law of energy conservation states that energy cannot be created or destroyed, only transferred or transformed. This means the total energy in a closed system remains constant, even if it changes forms. For instance, when you ride a bike, your body's chemical energy from food is transformed into kinetic energy to move the bike, and some is converted into thermal energy due to friction. But the total amount of energy remains the same. The energy conservation formula is E_initial equals E_final. In simple terms, the total energy you start with is the same as the total energy you end with, even though the types of energy may change. This includes kinetic energy, potential energy, and thermal energy. Take kinetic energy and potential energy as an example. Kinetic energy is the energy of motion, given by the formula Ke equals 1/2 mv squared, where m is the mass and v is the velocity. On the other hand, potential energy is the energy stored in an object due to its position, calculated as Pe equals mgh, where m is the mass, g is gravity, which is 9.8 meters per second squared, and h is the height. Let's take a pendulum as an example. When you lift a pendulum to one side, it has maximum potential energy because of its height. As it swings down, that potential energy transforms into kinetic energy as it gains speed. At the lowest point, all of the potential energy has converted into kinetic energy. As it swings back up, the kinetic energy changes back into potential energy. No energy is lost, it's simply transforming between forms. Now you might wonder what happens when objects slow down. That's where friction and thermal energy come into play. In real-life situations, some of the mechanical energy is converted into heat energy due to friction, making it seem like energy is lost. However, according to the law, the total energy remains constant. It's just transformed into a less useful form. So, next time you see energy transforming, whether it's in a roller coaster, a car engine, or even a pendulum, remember, energy is always conserved. The energy doesn't vanish, it just shifts between forms. Next time on, we'll dive into how this law applies to work and power and explore the efficiency of machines. Stay tuned. Like and subscribe for more bite-sized science that makes the universe easier to understand, one concept at a time.